Hey guys, welcome back to my channel. Today we are going to understand the concept of limits. It's very easy. Okay, so just let me give you a quick introduction. So in limits what happens is that there is a variable x, y, whatever. It is approaching a number, okay? So means what? If the number is 2 for example, so x is like 1.99 or 2.001 like that. So it's approaching 2, very close to 2, but not exactly 2. So what happens here is that there is a variable that is approaching a number. It's not exactly that number, but very close to that number. And then we are given a function. So in the function, what we have is that we have that variable and we have to find out the value of that function. So whatever number that variable is approaching, we will put that number in the function and get the answer. So for example, if I have limit x tends to 3 5 minus x, and I tell you what is the answer to this. So x is basically what it may be, like 2.999 or 3.001, so like that. And I ask you what's the value, so you don't have to do anything, just put the value of x and you get the answer. That is the very simplest kind of sum that you can get. However, it's not always like this. Sometimes what happens is that it's x to the power 3, maybe it's 5 minus x by x minus 3. Now, here I tell you what is the value of this. So, the variable is approaching 3. You put the value of 3 in place of x in place of this. So, you get 5 minus 3 by 3 minus 3. Now, here's when the problem occurs. You know that you're not allowed to have denominator as 0. You cannot have denominator as 0 because if in that case it will be undefined, right? Not defined. So what happens is that we cannot directly put x in place of the number. So whenever you're solving limits, always remember that I have to bring this whole function in such a form that the denominator is not 0. And so for that, there are three main formulas that you need to know. This will help you solve the sums that we are going to do. The first formula is limit x tends to a. Now, what is a? A is any number, any constant number. Okay, so one is the variable which is x. So if that x is approaching the number, a number, okay, and this is the form x to the power n minus a to the power n by x minus a, then I can write this as n a to the power n minus 1. I'll give you an example. So if this is the case, so here I have taken a as 2. If I have x to the power 5 minus 2 to the power 5 by x minus 2. So understand over here, this thing is exactly in this form. My a is 2 and n is 5. So whenever you have the two numbers with the same, they have the same power and exactly in this form, then I can write this as n, which is 5 into 2 to the power 5 minus 1, which is 5 into 16, which is 80. Okay, so this is example for this one. Let's look at the next formula. This is just direct. Okay, so here what we have, limit x tends to 0, e to the power x minus 1 by x is equals to 1. Over here, notice I can again not put directly 0 in the denominator. I told you that you cannot do. If however you have this form, now what is e is also constant, but it's different from a. It's a whole different concept. But whatever, if in your limit sum you have e, okay, then you just know you have to do just one thing, somehow solve it and get it in this form. What is this form? That e is in the power of x is the variable. So when e is in the power of the variable and variable is also there in the denominator, now see, it can also be like y minus 1. If it is like limit y tends to 0, so here y is the variable. If the variable is in the power and the variable is in the denominator, then in such a case I can directly write this value as 1. All right, same thing goes over here. Now a is any number, 2, 3, 4, whatever. If that is to the power x, x is the variable. If a is to the power variable minus 1 by x, then again I can write this as log a. So if suppose a is 2, and so you can write log 2 directly. Okay, so these three formulas are very important. You need to know them if you want to solve the sums. Now let's just solve the sums. Let's look at this first sum. Limit x tends to 1, x to the power 15 minus 1 by x to the power 10 minus 1. So here, obviously, what which formula are we going to use? This one. This formula we are going to use because this sum is exactly in this form. Okay, we need to do some changes, but it's exactly in this form. How did I know that we have to use this formula? First thing, I can see that x is approaching a constant number. X is the variable, it is approaching 1, it's a constant number. And also, x to the power 15 minus 1, this is in this form. X to the power 15, and a, what is a? A is 1, and 1 to the power 15, 1 to the power 15, I can write this over here. Correct. So this is x to the power 15 minus 1 to the power 15. Okay, so it's in this form. So what am I going to do? I'll do nothing. If I have x to the power 15 minus 1 to the power 15, and I need to bring it this form because this will help me write the value, what has to be in the denominator if I want this form? X minus 1, obviously. So I'll put x minus 1. Okay. Now, but now if I am putting x minus 1 over here, I have to multiply x minus 1 on top also. So this and this gets cancelled. And then I can write over here x to the power 10 minus 1. So what I actually did was this, x to the power 15 minus 1 to the power 15 by x minus 1. This whole thing is inside limit, divided by x to the power 10 minus 1 to the power 10 divided by x minus 1 whole thing. Okay. Now this can be written as limit x to the power x approaches 1. Now I can, individually I can do this. So basically I have x to the power 15 minus 1 to the power 15 by x minus 1 divided by limit, sorry, x tends to 1, x to the power 10 minus 1 to the power 10 by x minus 1. See what will happen ultimately, x minus 1 will get cancelled, and I'm going to get this back. And I told you that we have to solve this. You cannot add and subtract like this. If you're adding something, you have to subtract it. If you're multiplying something, you have to divide it because you cannot change this. Okay. So now this will become what? I can now directly apply the formula. I've got it in this form. C, x to the power n minus a to the power n by x minus a. This is my constant. The constant is over here, and they are multiply. They are, the exponential power is also the same of the variable and the constant. So now I will write the answer. It is 15. A is 1 to the power 15 minus 1 divided by 10 to the power 1, 10 minus 1. That is 15 by 10. Right? This is 15 because 1 to the power anything is 1 only. So this can be written as 3 by 2. So 3 by 2 is going to be the answer of this sum. Okay, let's move on the next kind of sum. So in now we have over here the second kind of sum that you can get, where we have d. So remember the formula, limit x tends to 0, e to the power x minus 1 by x is equals to 1. How do we bring it this in this form? Now here everything is fine. Just that there is a 3 over here. Just that there is a 3 over here. What do I do over here? Understand, the power of e, whatever power is there, the same power has to be in the denominator. So what I will do? I will do this. I will multiply the numerator and denominator both by 3. You can do this. So now we have limit x tends to 0, e to the power 3x minus 1 multiplied by 3 divided by 3x. Always remember that if I am multiplying something by a constant, I can bring this behind the limit. So I can write this as limit 3 limit x tends to 0, e to the power 3x minus 1 by 3x. Okay. Again, what I did, I multiplied the denominator and numerator by 3. Why? Because I have to match this and this. Because that's what the form is saying. I have to match this and this has to match. Okay. But they are matching, but still, and also with this also has to match. Over here it is limit x tends to 0. I have to make this x 3. Okay, so see one thing, if x is tending to 0, if x is approaching 0, that means x is equals to 0, not exactly equals to 0, very close to 0. If x is equals to 0, then 3x is also approaching 0. If I multiply 3 over here and I multiply 3 over here, it's the same thing, it's still 0. So now what I can do, I can write this as 3 limit 3x tends to 0, e to the power 3x minus 1 by 3x. Okay, and that means 3 into this whole thing is limit. Please don't forget the bracket. I'm forgetting to do this, but you don't. Okay, so one thing that you learned is that I can write the constant behind. I can multiply and divide with the same number if I want to bring it in this form. And this also you learned. Now this will be 3 into 1 because this answer is 1 over here, and so the answer is 3. Now a lot of you might be confused by what I did. If x is approaching 0, it means x is equals to 0, very close to 0 but not 0. It means that x plus 2 is approaching 2, right? If I add 2 over here, I have to add 2 over here. So basically, if x is approaching 0 means in the number line 0, x is very close, like it's over here, very close to 0, the value of x, but not exactly 0. So same thing is happening. If I'm adding 2, I have to write 2 over here. So basically 3x also approaching 0. X by 2 also approaching 0. Because x is approaching 0. That's the thing. Okay. So I can do this, all of these things. And this is important to do because in the formula, this x, this variable has to match with this, and all of those things. Okay. So you need to remember that. Next sum e to the power x minus e to the power 2. So this is actually 2x. I'm sorry, I wrote the wrong thing, but this is actually 2x by x minus 2. Again, e is there, so you know one thing that you have to bring it in this form, right? You have to bring it in this form. This is equals to 1. So now, how will we bring this in this form? First of all, this is not, this is x is approaching 2. So that's the one problem that we have. Okay, so I have to make this somehow x approaching 0, correct? How will I do it? So it's very easy. You don't have to do anything. Sorry, there is no 2 over here. I just wrote it by mistake. Okay, so now limit x tends to 2. Now how will I do this? I can write one thing, which is if x is approaching 2, then x minus 2 is approaching 0. Again, listen to me. What did I do? If x is approaching 2, x minus 2 is approaching 0. And let me say, let x minus 2 is equals to y. Let x minus 2 is equals to y. Why did I do this? This is why. See, limit y tends to 0. I assumed x minus 2 to be y. Okay. Now, in place of x minus 2, I will put y. So, e to the power x. What will I write? E to the power y plus 1 minus e to the power 2 divided by y. How did that happen? Understand over here. If x minus 2 is approaching 0, that means y is approaching 0. So what am I doing? Let x minus 2 is equals to y, which means that x is equals to y plus 2. And over here, in place of x, I am using y. I cannot have two variables like at the same time. It will be problematic. So I have to use one variable. Instead of x minus x approaching 2, I wrote y approaching 0, which means that x, as I've explained over here, x approaching 2, x minus 2 is y. Alright. Next, what I'll do, limit y approaching 0, I will take x to the power 2 as common. So I have e to the power y, e to the power y minus 1 by y. What did I do? Let me explain again. We said that x minus 2, let x minus 2 be equals to y. Since x is approaching 2, so x minus 2 will approach 0. So now we got y is equals to 0. So one problem solved. This one. Now I have to bring this form. In case of x, I will put y. So I have put y plus 2 because why? Because if x is approaching 2 and y is approaching 0, that means x minus 2 is equals to y. That means x is equals to y plus 2. Now I did this, so I wrote it over here and I wrote e to the power 2 because that's whatever is given by y. So now if I take e to the power 2 common over here, then I can write this because again if I multiply it, I'll get y plus 2 and then the same thing I'll get over here. So it's e to the power 2 into 1. This is the form that I wanted, and that is e to the power 2. That's your